Hello, guys. Good evening. Hope everyone is doing well today. So, this is our fifth part series in our Python series. So, we are still continuing with the list. So, if you haven't checked on our previous videos about list, please go and have a look on it because those will build your fundamentals so that if you come to this stage, you'll have a firm idea and you would have a good foundation on what you're about to learn. So, I hope you all go and have a look on it and then come to this video if you're new here. So before we start with our video for today, who are we? We are Data Valley, the fastest growing edtech company of 2025. And myself, Franklin, I have almost 3+ years as an experience as a data engineer, and I'm very glad to bring this video to you. As I used to say in my other videos, this is not just any other video. This is from our foundations of experience, and it is not just mine, it's not just individual experience, but it is a combination of different people, every colleagues who have been through this process and what they underwent. So this is a combination of all the knowledge that we could bring to you. So please make sure that you pay attention and learn as much as possible. And if you have any friends who are aspiring to become a Python developer or anything in relevance to Python, even if it is a data scientist or a data engineering role, whatever they are aspiring to be, but if they have anything to do with Python, please feel free to share it with them as well so that they'll be benefited out of this. So feel free to check out my profile in LinkedIn, and let's connect there, let's talk, let's network, and let's build a community where we discuss about technical stuff. So I'd be more than happy to connect with you. So today, what are we covering? We are covering the fifth part of our Python series. And to give you a glance of what we looked in the previous videos, so what did we see? So from the part 3, we started looking into the list. So first we started with what is a list. We had a look on the key characteristics of the list. Then we looked into few methods and functions that are applicable to a list, which includes functions like append, where you add an element to a list at its end position. And then we saw about extend method, where all the elements from a different list are added to your existing list as a single item. So that's the difference between your append and extend function. And with insert, you get to specify the index position where you want to insert your element. And then we had a look on how to remove the elements. So remove will remove the element at its very first occurrence, and pop, it has two functionalities. Either it'll remove the element from a particular index position, or by default, if you haven't provided any argument or index, it'll get to remove the element from your last position. And then you had a look on how to clear your list, and then we had a look on index method, where you get to access the index of your particular element. So if you provide the value of a particular element within a list, you get to know the index position where it is found within the list. And then to the next series, we covered few more Python functions, which includes the count function. Then we covered about the sort method. So in count method, you get to know what is the frequency of a particular element getting repeated within a list. And in sort method, you get to uh, arrange your elements in a particular order. So either it is ascending or descending. And in an advanced way, you can also use certain functions using your key argument, where the sorting criteria will be based on the function that you provide. And then we had a look on the reverse method. So whatever the elements you have in a list, they get reversed entirely. So irrelevance of whatever the element type or element is, their positional indexes just get reversed. So if it is in the start, for instance, let's say the first position is 0, then it is 1 and 2, but it just get reversed to the last position. So that'll be -1, -2. So the positional index get reversed, and therefore you'll be having a new, the existing list that is reversed. And then you learned about creating a shallow copy. So you use a copy method, where all the elements from your existing list are created into a new list, where all the elements in the copied list are referenced to your previous element. And then we had a look on the enumerate function and zip function. So enumerate function creates a enumerate object, where a counter function is initiated and the index of the elements are followed through. And then you had a look on the zip function. So zip function is where you make a single object out of two or more iterables. So let's say you have two or three or any other iterable types. When you use a zip function, you merge them into a single list. And then what happens here is you create a tuple of list, right? So because there is a combination of the elements, like for instance, let's say you have the first element from your first iterable and your first element from your second iterable. So anything that is placed in this first position gets merged. So you form a tuple out of it. So you get a list of tuples. So and then also you learned about the unzipping operator. So an unzipping operator is a asterisk. So that will unpack your zipped elements. Okay. So today, what are we covering today? So we are talking about few more operations or methods or functions that you want to call. So we are going to cover few more operations in list. So to start with, we will cover what is indexing operation in a list. All right. An indexing operation in a list is a process where you access individual elements within a sequence using their. So you specify the index number. By specifying an index number, you get to access the particular element from your list. And we have previously seen this in our previous videos. How does the indexing work in a list? The indexing in context to Python starts from 0. So generally, when you have a list, generally when you have few items, how would you start your positioning from? You start from first, the second, the third, the fourth, right? It goes onwards. Talking in context to Python, the indexing starts from the number 0. So whatever the first element is, the positional index of the particular first element is 0. So onwards it is 0, 1, 2, 3, and onwards. So make sure you know about indexing, and indexing is a very crucial part because using index you will get to access or update and modify the list. So you perform multiple functionalities based on accessing the index. So be sure that you are well thorough about your indexing operation. And then what are the key aspects of indexing? So let's see few aspects within the indexing operation. First one is it is indicated using a square bracket. So elements that are to be accessed or placed within their index. So elements are accessed by placing their index. So what do I mean is that whatever the elements you would like to access within a list. So let's say you have 4 elements within a, okay. So how would you access the 4? So what is the number for each of the 4 elements? So it goes like 0, 1, 2. So yeah. So what happens? You gotta specify it, right? So when you specify it, you get to access the particular element. So if I indicate, let's say the index to be number 2, I'm going to get the third element within a list, and they are mentioned within a square bracket. So make sure that a square bracket notation is required to access an element based on the index. And then there are two functionalities within indexing. The one is positive indexing and the next one is negative indexing. So what do I mean by positive indexing and negative indexing? So when you access the element from the first position, it starts from 0, right? But 0 is not a negative number, just to let you know. So 0 is a neutral number, right? So talking about positive indexing, it starts from it starts from 0. So it goes onwards like 0, 1, 2, 3. So it's a positive integer or a positive indexing number. And talking about negative indexing is that if you would like to access your elements from your end of the list, so how would you access it? Let's say you have a scenario where you have like 10 elements. For 10 elements, you would know that, okay, there are 11 elements and the positional index ends at 10. But for worst case, let's say that I have something like 500 elements and there is not a efficient way to access your last element. To solve this, you have the concept of negative indexing. So all you gotta do is you just have to start your indexing with the minus number. So when you specify -1, you would get the last placed element. So -2 would indicate the second last from your end of list. So minus or negative indexing starts from your end of the. So as we have for positive indexing, it goes onwards, right? So it goes like 0, 1, 2, 3, 4. Similarly, for negative indexing, it goes onwards, but in a reverse format such as -1, -2, -3, and -4. Okay, for an implementation today, let's see a few examples. I've gotten here a list which is called as my list, and this is having few elements such as apple, banana, cherry, and date. So all of these are string type. So I'm having a list which has only the string type. Talking about indexing, so let's see if it is a list first. So if I run it, we would be getting a list printed. And in here, I would like you all to pay attention to know what is the index portion. So for in our case, let's say, oh, the problem is because I didn't run the first code. So my list, I've created my list and now I'm printing it. So in the above code, how would you rate your positive indexing and your negative index? So if you would like to number, apple is 0, banana is 1, cherry is 2, and date is 3. So this is the positional index of your elements from your my list, and especially we are talking about the positive index. Okay, how would it work in the concept of negative index? So if you like to access the same elements, how would you access it using a negative index? So it's simple. As I said earlier, it starts from -1. So talking about -1, it doesn't indicate this element, but it starts from the last portion, right? So date is your -1. So -1 is your date, and cherry is at -2, and banana is at -3, and apple is at -4. So this is how your positive and your negative indexing works in a indexing operation within a list. Let's try to access few of our elements using positive index. So what elements would I like to access? So I would like to access the element at 0, and I would like to access the element from number 2. So what are the elements do we have at 0 and 2? So if we consider 0, 1, 2, 3, so 0 is apple and 2 is cherry. Let's run this code to check if we are getting there. But before we jump to that, I would like to reiterate on the syntax. So as you notice here, I've got my list name, right? So this is my list name. Then I've used a square bracket notation. So within the square bracket, I'm indicating what is the positional index I would like to include in here, so that I get to access the element of that particular index. So I'm indicating number 2 here. So for this positional index, get me the element. So that's what we are telling to this code. I hope this syntax is very clear. And now let me run it. So as in the way we have learned, we can see that 0 has given us apple and 2 has provided us with cherry. So this is how you use positive indexing to access your element. And now talking about the concept of negative indexing, it's again the same. So you specify your list name. So in this context, we have my list, and then you denote it using a square bracket, and then within the square bracket you denote the index. So talking in context to your negative indexing, how does it work? It starts from -1 and onwards. So in this context, if it is -1, we would be getting date. Am I right? Because it starts from -1. So -1, -2, -3, -4. So if I want -1, I'll just put it in a reversal way, so that when you look into the notes, you get a better idea. Yeah, I'm just changing it because if you don't listen to this video and if you just look at randomly, you're going to be confused of how did apple get -1 indexing. So I don't want you to be confused. So this will help you. So if I'm accessing it using my negative indexing, -1 would denote, and -3 would denote banana. So let's check it. Yes, we are right. We have got date and banana using our negative index. Okay, I have a small doubt now. So have we done any in-place modification? Talking about the Python operation, it has nothing to do with in-place modification. There are few functions where we get in-place modification. So what do I mean by in-place modification? An in-place modification is where your original iterable gets altered, right? It changes entirely. So that's what is all about in-place modification. Talking about the operations within Python, you don't have any kind of in-place modification. So as soon as I print my original list asking for the first element, so I've given the first positional index, it has given me banana. So there is no in-place modification. Let's check it as well. Okay, so print my list. So we have got our original list as it is how we have provided. So apple, banana, cherry, and date. Apple, banana, cherry. And now there is a way that you can modify an element using the indexing concept. So indexing is not just a technique to access your element. Using this particular indexing concept, there is also a way that you can modify an element within a list. Let's see how to do it. So if I specify my list square bracket notation 1, what is the element I would get? So this is 0 and this is 1, right? So banana is my element at number 1 positional index. Okay, so now what I'm doing here is I'm just accessing the element. So this is the way you access the element. And because Python is a dynamic language, what do I mean by dynamic language? The variables and its value can be altered at any stage of your code. For instance, let's say you're starting your code with a is equal to 5, and then later when you set a is equal to 10, the value can be modified at ease. So, and if you run your code at end, all you will be getting is the latest value that you provided. So just to show you a quick example, so a is equal to 5, I'm printing it. Okay, print a. And now let's say I am specifying a is equal to 10, and then I'm again printing it, print a. So what is the element that we are getting? It's 10. So you might be wondering, is it just because we placed print next to our element specification? No, whatever the last value that you specified becomes the value for your particular variable. So I've ran it again, and you can see that whatever the latest value that we are provided becomes the value for that particular variable. All right. So before we jump there, let's talk about the modification within an indexing. So using this code bit, I get to access my element. And now, because Python is a dynamic language, as you have seen with example, all I got to do is I'm going to use an assigning operator, which is equal to, and then I'm specifying I want that particular element at that positional index to be blueberry. So when I change it to blueberry, and now when I print it, so this was our original list, right? Apple, banana, cherry, and date. But see here what we have got now. So we have got apple, blueberry, cherry, and date. So banana has been modified to blueberry. How was it done? By accessing our element at positional index 1, which is banana, and by using assigning operator to be blueberry. Hence, we have changed our element. So this is how you use the indexing operation to alter your elements within a list. Cool, easy stuff. I hope this was easier. And now, to extend further on this concept of index. So what did we do in indexing? In indexing, we get to access an individual element using the number specified. But in slicing, it is quite different. How is it different? So what do you mean by slice? Let's say I have a banana, and if I'm slicing, what happens? So if I'm slicing at the center, I'll be getting 2 pieces. If I'm slicing twice, I might get 3 pieces. But the point here is not that I get 3 pieces, but when I slice, I get something that is very independent, right? So whenever I slice something, I get to take certain part out from that full length of element. So even, let's say, even you consider your banana part. So you have your banana, you slice it twice. Okay, you cut it in 2 different places. So when you cut 2 different places, you have the beginning part, the middle part, and your end part. So let's say you want the middle part. So you have sliced it, right? You have sliced it out from the full banana. Similarly, talking about slicing in list, you will be having a list, and from that list you'll be slicing out a section of elements. So you'll be cutting off, or you'll be taking out few elements from that particular list. Let's see deep with the definitions. So slicing in Python is a powerful feature that allows the extraction of a subsection or a new list from an existing list by specifying a range of indices. So you get to extract a subsection of your element, okay? And then from that, either you can create a new list or you can just extract. And then how you do it? You do it by specifying a range of indices. So in the above, we specified a single index number, right? We just specify numbers like 5, 2, 3, -1, -3. So these are the positional indexes that we use. So in context to our slicing, you specify a range of indices. We will get to there how to specify this range, but just know that slicing, you specify an individual index, and in indexing you specify an individual number, but in slicing you specify a range of indices. Okay, what happens when you create or when you slice a list? It creates a shallow copy of the selected elements, leaving the original list unchanged. So we yesterday saw about the concept of shallow copying, right? So you use copy command to get another list, which is reference to your previous. Similarly, what happens with slicing is that you create a shallow copy of your selected list, but no matter how you slice or extract the particular subsection from your list, your original list remains unchanged. So slicing doesn't use any in place modification, rather it is just independent to your in place modification. So the original list just remains as it is. In other way, you create a new list. All right, so let's see the syntax. The syntax goes like this. You specify your list name. So same as in indexing, right? In indexing, you specify your list name. You use square bracket notation, and then you have three different parameters within a slicing concept. This three parameters within your slicing refers to your range. In indexing, all you gotta specify is one individual argument, which says that what is the position are you looking for, what is the index, no, what is the element at particular index you are looking for. But talking about slicing, you have to specify it within a range, and you got to know that all these three parameters, the start, the stop, and step, these three are optional parameters within your slicing operation. Okay, let's dive deep to know about all these arguments, and then we will further discuss about the syntax. Okay, as I said earlier, it takes in three parameters: the start, stop. So what is a start parameter? So start parameter is where your slicing begins from. By definition, the index from where your slicing begins, inclusive. So as I said earlier, the slicing begins exactly from this positional index that we provide. Let's say you have a list with 5 elements ranging up to 1 to 4 positional index. In that case, when you provide your start position to be number 1, you're not going to get access to your elements which are 0. The positional index 0 will be ignored, and your slicing starts from number. Okay, in that way, if you actually look, this is inclusive. Why did I specify inclusive? When we do the coding part, you will have a better idea about it. For now, just understand that whatever the beginning number or whatever the start number that you provide, you will be slicing it included. So let's say you have numbers from 1 2 3 4 5, and I say start your slicing for number position. So in the context of Python, I'll be accessing my element from 2, right? So 2 3 4 5, so that would be my sliced part, and I would leave out the element. So your slicing exactly starts from the position that you specify at the start, and then if omitted, it defaults to 0, the beginning of the list. As I said earlier, start is an optional parameter. In that case, when you don't provide a number or an index position, what happens is that by default it starts from the beginning of the list. So if you specify, it starts from whatever the index position you provided, and when you don't provide a number, it starts from the default positional index 0. And then to our next parameter, the stop. So stop parameter is where do you want to end the slice from. So by definition, it's an optional parameter, and then the index where the slice ends, exclusive. So why did I specify exclusive? So if you would have known about Python indexing or a range function, you would be aware that when you set a range, whatever the end number that you have specified, your list gets to access one before the particular number. So let's talk in our same concept. So let's say I have number 1 comma 2 comma 3 comma 4. Okay, this is my elements. And then talking about the index, how is it? So it starts from 0 comma 1 comma 2 comma 3 comma 4. So this is the index portion of the above element. So when I slice, what happens is that, so let's say I want to slice from you just want the elements from 1 2 3, you want to slice from 1 to 3. So what happens is that you specify that, okay, access from this push. So I get to specify my start portion, which is fine, and then I use a colon, and then because I would like to include this. Okay, I want from 1 to 3. So 1 2 3, I want all this I gotta specify that 4 is my end number. Why is that? Because if I specify one lower, it is exclusive. Okay? If I specify the exact position, end is exclusive. That is, it is not included or dropped off. Okay? So be sure that for start, you can specify from your start position, which is fine. But for end position, make sure that you always specify one range higher because it is an exclusive form. And then the element at this index is not included in this slice. So that's what I meant by exclusive, right? And then for start position, you know that if you exclude it, it defaults from 0. So what would happen if I don't specify the positional index for the stop parameter? So what happens is, as in the start you get to access from the beginning of the list, with stop function it goes till the end of the list. So for the start, if you don't specify, it starts from the beginning of the list, and for stop parameter, if you don't specify it, it goes further to the end of your list. Then the step function. The step function is how you would like to increment your indices. What do I mean by increment? So talking about incrementing, it just specify that how many elements would you like to skip. By default, if you don't specify anything, you are not skipping any elements, and it just means that, okay, by default, if even if you don't specify it, as it is being an optional parameter. So what happens is it skips one. Sorry, it doesn't skip one. Okay, so let me show you an example. Okay, so this is my list, and when I want to use step function, by default it is 1. So it says that one element higher. So when I specify 1, it just means that go one element higher. So 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5. So that's how your step function works. But let's say I'm specifying, okay, and my start position is from here. So 1 plus 2, go to 3. My 2 is skipped. And again, I'm specifying a step 2. So 3 plus 2, so I'm ignoring the element 2 and 4. Why is that? Because my step function is incremental by 2. Also, you got to understand this. A negative step value reverses the order of the. So when you specify a negative number for your step parameter, you get to reverse the order of the slice. Without further theory, let's see how this works in our practical code. So as you see here, I've got a list here which goes from 10, 20, 30, 40, 50, 60, 70, 80 up to 90. So this is my list. And when I print it, you can see that yes, it is a list. So this is my list. And now what I'm trying to do here is I would like to slice from up to, okay. So I want to get the slicing for my particular list. Okay, I would like to slice from my particular list from the positions to up to index. You just have to be sure that when you specify 5, you're going to exclude the value at number 5. So by this concept, let's say before we run the code, let's see how it works. 0 1. So if I've specified 2 at the start, so 0 1 2, so 30 is going to be covered. And then what is the third? 40. What is the fourth? 50. It doesn't go to 60. The reason being, whatever the end position that you have specified at your end parameter, it doesn't include it because it excludes the value. Okay, it excludes. So it stops one step before it. So if I run this, I must be getting 30, 40, and 50. And yes, we are right. And by syntax, you can see that I've specified my list name, and then I'm specifying my start and end position 2:5. Let's see in the above just before we jump to the other codes. So I said I'll explain this code further, the syntax further. So as you see here, I specified start colon, stop colon, and everything being an optional parameter. So you necessarily don't have to specify it. Even if you say that colon colon, it is just going to give you the entire list without excluding anything or altering anything or without any further modification to your original list. Okay, but be sure that when you try to use this parameter, use the colon function, and when you don't specify any number, you get the full list as it is. Okay, so let's jump further again. Okay, we have seen how to do the indexing for the elements from 2 to 5. And now for my second question, what I want to do is slice from the beginning to a specific index. So all I want to do is I want you to slice particular section from my list stop it at a specific. Before we jump further, let me print the index number here so that it is very easier for us to understand further. So we have elements 0 1 2 0 1 2 4 5 7 8. So we have up to 8. So 0 comma 1 comma 2 comma 3 comma 5 comma 6 comma 7 comma 8. So this is the positional index. And now what I'm trying to tell here is that slice from the beginning to a specific index. Start from the first and end somewhere. So it could be anywhere, right? Anything before the end. So even I can stop at 6. So what I'm trying to do here is I haven't specified anything for my start parameter. Do you know why? Because first things first, start parameter itself is an optional parameter. And when you use the slicing and when you don't specify your start position, by default it starts from 0. Okay. So the reason I have specified 0, I haven't specified anything here is because it starts from 0 and there is no need for me to specify any position like 0, because as you see in here, let's say in the above thing, I would like to access my element from 0 is to 5. It is going to give me the same, right? 10, 20, 30, 40 and 50. So there is no difference if I specify 0 or not. Okay. And in this I'm saying cut at the positional index 4. So where should it stop? 0, 1, 2, 3 and 4. It would stop here. No, you're wrong. It would stop at 3. You know why? Because 4 is exclusive. The end parameter is exclusive. In that context, I should be getting elements from 10, 20, 30 and 40. Let's verify if we have worked it out right. As you can see here, yes, I've got elements from 10, 20, 30 and 40. Okay, and now slice from the specific index and I want till the end of my list. So in here we wanted to start from the beginning and end at specific index. Now what I'm trying to tell is, okay, start from the specific index and go till the end of the list. By in this context, if I specify 6 colon, where does it go? So it is going to get the elements from 6, 7 and 8, which should be 70, 80 and 90. Because I haven't specified any index, it goes till the, and when I run it, you can see that yes, I've got 70, 80 and now when I print my original list, you can see that nothing has been modified. So my original list, it is still existing and it is the same as we have created at the beginning. And then let's go with the step function. Okay, so we have seen how to use the slicing from the start and end parameter using end and using start and your stop parameter. Now talking about your step, I've already said you that this is the incremental value that you provide, or the incremental number of indices you provide to your slicing operation. For in this case, what I'm doing is, okay, get the elements from 1 is to 8. So what is 1 is to 8? So it starts from the positional index 1. So 1, 2, 3, 4, 5, 6 and 7. It stops here because whatever the end parameter 8 is, it just gets subtracted by one index. So 8 is exclusive and you are just including up to the 7th parameter. Okay, and now I've specified my step to be what would happen if I have given the step to be. What happens here is that, so if I'm starting from here, when I say, so it says that go to your second element from here. So first element, second element. So 30 is my element after 2 steps. And now I'm saying, okay, go 2 steps further. So first step, second step, 50. 1 step, 2 step. So this is 70. 1 step, 2 step. Simple. So wherever the step lands, that's what you get printed. So by default, it is 1. So plus 1 step, 20. Plus 1 step, 30. Plus 1 step, 40. As you have seen already, if you provide number 2, it is going to ignore an element and jump to the second element. So let's see how this code works when we print it. You have got 20, 40, 60 and 80. Why? We started from the positional index 1. So we are going to get the element from here. And we stopped at number. So it is going to skip the 90 and it is going to be here till 80. Okay. And now I've said jump to incremental. So 20 because we started it. First element, second element, 40. First element, second element, 60. First element, second element, 90. So that is how you use your step function. And also I said you an important operation about using the step function to reverse your slice. Let's see a simple example of how I have reversed my entire list. So As you see here, I haven't specified any number, but I've used colon function, just denoting that have your default value. Okay, have your default start and have your default stop position. And now I'm reversing the list by indicating with a negative value. So because I have specified it with a negative value, it is just going to reverse the list. And similarly, you can use -2 as well, because in that case you would reverse the list and you would skip an element and then print the second element and further. All right, so whatever your second element from your current element, you will get to print it. All right, so now let's see how we have reversed our list. As you see here, by default I have accessed the full element. So go from the start to the end, which is from 10 to 90, as you have seen, as you can see here. And now what I have said, okay, to this I want you to reverse my, because I have specified -1, my entire list has been reversed. So 90, 80, 70, 60, 50, 40, 30, 20 and 10, which is completely different to our original. Now let's talk about the looping operation within list. What is a looping operation? So looping operation refers to the process of iterating over each element within a list to perform. Let me increase the size a little bit. Okay. So a looping operation refers to the process of iterating over each element within a list to perform an action or access it. So what do I mean here? I have a list with, let's say, 4 elements. By looping, what would happen is I would access the first element, I would exit the code, go for my second element, exit the code, go for my third element, exit the code, go for my fourth element, exit the code. So what's happening here is I'm running a loop, right? So access 90 first. So if you see in the above example, I would go to 90, exit, 80, exit, 70, exit, 60, exit, 50, exit. So that is how you use your looping function. And to perform looping operation within a list, you have two types. The one is for loop and the other one is while loop. We will see the difference fairly soon enough, but first we will cover about the for loop. So in for loop, the method directly iterates over the elements of the list without needing to manage your indices. So in the for loop, you don't have to mention any indices. Okay, all you gotta do is you specify the list name, and then from then onwards, all the elements are accessed in a loop formality. I've got an example here. I'll show you how this works. Okay, I've got a fruits, okay, which is a list name. So your list name can be anything. I hope you all are very sure about it, and you're, at least to some levels you have, built your fundamentals. So you know that fruits can be any variable. And then I'm using a square bracket. Then I'm specifying the elements within the fruits list. So I'm specifying cherry, banana, and apple. So these are the elements within my list called fruits. Now what I'm trying to do here is I want to loop through each fruit in my fruits. So I want to access each of my elements within the, so how would I will access it based on the loop function? So apple, banana, cherry. So that should be my looping operation, right? Because each individual elements are accessed one by one. And now here is my simple basic code to run a loop function for my, so the keyword here is first you have to specify for. So for would denote that you're trying to use the for loop for your looping operation. For fruit and fruits, you might be wondering, why have I specified fruit? It is just a naming convention. So you can specify anything. Let's say I can specify even elements. So in that case, if I try to print this, I would still print it. So it has printed me apple, banana, and cherry. Is that necessary? Should I print just elements? No, you can use any naming convention of your choice. So I'm just printing X. It gives me the same code again, apple, banana, and cherry. So this is just the naming convention. So to, for better code readability, I've specified it to be, so for fruit in fruits. So fruits is my list name, right? So I'm specifying my list. So be sure about your syntax here. For element in my list name, then you print it to see what is the element you have within your list. Not necessarily that you have to use print function here. It can be any block of code. But just for a quick demonstration for today, I've used. So what has happened in the above? In the above, a looping function would iterate through each element, right? Individual element. So what has happened here is, first the code ran, okay, for fruit and fruits, print the fruit. That way, first it would print the apple, okay, it would exit, Once it has exited, goes to your loop again, then says okay, print banana. Then the code gets exited. Once it gets exited, it goes to your fruit again, says print the fruit from your fruits, and now it would print the cherry. Okay, so this is how your code works. So it would loop, exit, loop, exit, loop, exit, and that's how your for loop works. In the above, fruits is your list containing the three strings. We have seen that. And then for fruits and fruit statements assign each element of fruits list one by one to the variable fruit in each iteration. So what's happening here is whatever the naming convention I've used here, this naming convention gets applied to each element within the list. So yes, this is a fruit. Yes, temporary name, this is a fruit. Yes, cherry has a temporary name, fruit. So that's how for each of the element it gets assigned for iteration purpose. And we have got print function just to show that whenever the looping works, what gets printed out. Okay. And now also with the loop, you can use range function and length. I'll show you an example here. Okay. For loop doesn't support your accessing your iteration based on indexing functionality. So as an alternative or a complementary operation, you use range function and length function to access your indices and then get it printed. Okay, and this is particularly useful when you would like to access each index of your element in addition to the value that you have got. Okay, so in the above you see that we haven't specified any index, but still we managed to print the elements out. Similarly for indexing, by using your length and your range function, you get to print both your index and then you get to print your value as well. So what do I mean by print is that you can access it basically. So print is one simple functionality to demonstrate it. You can access the index as well as the elements within the list. Let's see a small example here. I've got a list called numbers, which is having 10, 20, 30, and 40 as its value. For I in range. So I is a naming convention here. We have just seen it, right? So this is your syntax for elements in list. So this is your syntax. So this is my element name for I in range. So to how am I printing it based on my range function? So what's happening here is, let's say numbers. So numbers is your list above. What would length of numbers get you printed? So length is going to give you the value as an integer, which denotes that what is the number of element within a list. So you have 4 element within a, so length of numbers would return, right? And now what I'm telling is range up to 4, and you got to understand that 4 is exclusive, so it gets to print only up to. And then I'm using a print statement to show you that element at particular index, the value of that particular index is the value of that positional index is this. Okay, so what's happening here? See here what I've done. So I've got 10, 20, 30, and 40. I've accessed the index. So each time the for loop runs, it accesses. Okay, index 0, index 1, 20, index 2, 30, index 3, 40. So how has it been done? So it goes here. Okay, what is the element at 0? 10. Okay, print it. Go to index 1, print 20. Okay, go to index, print 30. Go to index 3. So that is how you loop through your and print your element. A short context in the above, length returns the number of elements in the numbers list, which is an range of length of numbers generates a sequence of numbers from 0 up to 4, but not including, which represents your indices. The loop then uses numbers I to access the elements at the current index position. So as I said earlier, length gives you the value of your list, which is a total number of element within your, and then range function, whatever the n number is, it is exclusive. Okay, so what do I mean by exclusive? The number 4 gets excluded, so you get to access only up to 3. Okay, and then we have the next functionality called while loop. What happens in while loop is that in for loop you have a definitive, or you have a known number of elements within a list which you are going to access. So you have definitive number how you are going to access the elements. But in while loop, it doesn't work based on a particular number of time. a while loop works based on a condition. So to give you in a simple context, let me explain it like this. You go to your college or you're back from your work. Once you're back from your college and your work, now you're sitting just relaxed and you want to grab your biscuit. You eat the biscuit, and now there is a question in your brain: are you hungry? If the answer is yes, then you eat your biscuit again. And now you ask again, okay, should I eat another biscuit because I'm not sure what is my condition? If I'm hungry, I'm going to eat the biscuit. So as long as you are hungry, you're going to continue eating the biscuit. Similarly, a while loop works with such a conditional clause. Whenever a condition is true, okay, in that particular instance, the loop gets continued. So as long as the condition is not satisfied, the loop will run through again and again. Okay, it is simple, but though it is simple, it is very less commonly used in the simple operation, because usually it is for a loop, because it is definitive and you know how many times you're going to loop through a particular okay, let's see here. I've got a list called colors. I've got red, green and blue within a list. The length of my colors is 3 here. I will show you why I've specified it, but just to know that length of colors is 3. Why? Because it has got 3 elements: green and blue, 3 elements. And what I'm doing here is I'm using a while condition to print all the elements within a list. Okay, I want to print all the elements within a list using a while loop. So what I'm doing here is I want a condition to be satisfied. So to initiate this condition, I'm specifying index is equal to 0. And now here is my while clause. So my while function, I always have to, for my while loop, I always have to use while keyword. So for loop, you had a for keyword, and for while loop, you have the while keyword. While, and here is my condition. So the condition is as long as the index is less than the length of the colors. So what is the length of colors here? 3. So we are initiating our index number with 0. So as long the index value is less than the length of your colors, print the colors along with its index. Okay, and then while you loop through each, add one element again and again to your index. So if I run this, you can see that I've printed red, green and blue. Talking initially, what has happened here? What has happened is I'm initiating my index variable with 0. So that is how I'm initializing. And the while loop continues as long as the index is less than the length of the colors list, which is 3. So as long as it is less, the loop will continue. And now what happens is in each iteration, the element at the current index is printed and index is incremented. So as you see here, okay, I didn't print the index. So as you can see here, my index gets printed along with the color as well. So the element at the current index is printed and the index is incremented as well. How do I know it has incremented? Because I'm using a formula here which says that index is equal to index plus 1. So whatever the index current index value is, add 1 to it. So in here it has looped first. Okay, red is at 0, printed. It has exited, but while before exiting it has got an 1 value additional. So 1 is less than 3. So because it is 1 is less than 3 and the index value is 1, it gets to access green, printed. And what is the index? Number 1. Okay, loop exited and it has got the index plus 1. So now the value is 2. 2 is less than 3. Okay, printed, print the color and the index, add one more index, and now the index becomes 3. So 3 less than 3 is not possible, right? So as long as if I at least specify index less than or equal to length of colors, then another loop would have run. But because I've specified my loop number to be 1 lesser, it wouldn't work out. Okay, so that is how your while function works. What is a comprehension operation in a list? So list comprehension in Python offers a concise and efficient way to create new lists based on existing iterables like list, tuples, and so list comprehension is very simple. This is a way that you write a concise code. We will see in detail about how to write this concise code. But for now, you have to know that list comprehension is an operation that you use within a list where you try to write a concise and an efficient code, and in which you also create a new list as well. So this is not an in-place modification or not an in-place operation, but rather using comprehension, I mean the list comprehension, you create a new list as well. It combines the functionality of a for loop and optionally an if condition into the single line of code, often resulting in more readable and compact expressions compared to traditional. So what's happening is In the above example, you saw how to write your for loop, right? So this for loop at least had 2 lines of code, minimal, okay? We had at least 2 lines of minimal code. But in list comprehension, you do not even have to worry about 2 lines of code, because you'll be writing the for loop so concise that you get only 1 line of code. And in the above for loop example, your code was very simple, right? It was just a print statement. But in versional or a complex work environment, your for loop would be so bigger. But do not worry, in future videos we'll be covering about complex for and while loops as well. In that case, what happens is that you get to write a concise code using the functionality of a for loop, and then also you get to specify an optional condition statement as well. So what is a list comprehension? So in list comprehension, you create a new list based on the functionality of a for loop and an if condition as an optional parameter. So this is a compact way of writing, or a compact expression compared to your traditional loops. So I will explain that in the further video, so you will get an idea about it. Talking about the syntax, it takes a square bracket because we are creating a new list, right? So we are creating a new list, so it is denoted by a square bracket. And then expression for item in iterable if. So this if condition is an optional parameter, so do not worry about it. So expression, what do I mean by expression? So expression is a argument here, right? The syntax keyword. So this is the operation performed on each item that is included in the new list. It can be variable, a function call, or any valid Python. So what we are trying to tell here is that I want this particular expression, I want this particular functionality to be implemented on each element of my iterable. Okay, as you see here, I've already said you it combines a functionality of a for loop and an if condition. See here, this code would make sense now. For item in iterable, so this is how you write your if condition, right? Sorry, your for loop. So the syntax for a for loop is that for item name in iterable name, right? Your list name, it can be anything, and iterable can be anything, right? A list, tuple, dictionary, whatever it is. So this is your syntax for your for loop. So now what I'm telling, for this loop, try to use this expression for each of this item. So implement each of this expression to each of this item within my iterable. And then here I have my if condition, which is an optional parameter with definition. This is a temporary variable that represents each element from the iterable during the iteration. So item or whatever the alias that you're using, that is the temporary variable or a temporary variable name that you provide to each item within your iterable. An iterable can be anything such as list, tuple, range, a dictionary. So this is our source sequence from which the elements will be accessed and processed. Then we have if condition here, and this is a filter that determines which items from my iterable must be included in my new list. So in list comprehension, I'm creating a new list. I'm using a for loop to iterate through my iterable. I'm using an if condition to provide a conditional clause. And then in this if conditional clause, I specify certain conditions which would determine which items from my current iterable should be included in the new list. And you got to understand that only those elements that have specific what is that? Only those elements that have met the specific condition gets to be added to your new list. All right. So not all the elements get printed. Only whatever the elements that gets qualified for your if condition gets printed in your new list. Let's see a basic difference between a for loop and a list comprehension. I've gotten a for loop here, okay, which we'll be implementing in the list comprehension below. So what's happening here? I've got a list here, numbers. So it has numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've got a list. I'm creating an empty list called even numbers. Okay, simple. So I've got a numbers list and I've got an empty even numbers. Now I'm running a loop function for numbers in numbers, for num in numbers. If, so I've got an if condition as well. If number is not an even number, because I've used a percentage symbol, which denotes that if the number is not divisible by 2. Okay, so this is an check operator, right? So this is a check operator. So if it is not divisible by 2 and not equal to 0, so whenever the number gets divisible by 2, the remainder is 0, right? So the remainder is 0 here for the even number. In that case, what I want to do is add or append. Append is the function, right? So add that particular number to the empty list called even numbers. All right, is this very clear? So I'm using an append function to add element at the end of the even numbers, which is an empty list as of now. But you get to add only that is of even number. Okay, let's print this. In here, you know that your original list had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And in here, for your new list, which is even numbers list, you have used an if condition, which gets you to, filter your elements based on the even, based on if the numbers are even. And once it is even, it gets appended to your empty list. So you can see that you have got 2, 4, 6, 8. Well, good, you all know about for loop. But let's see how this would work with your list comprehension. Okay, in list comprehension, what happens is that I've got my list, the same list, the numbers list, right? This is same, isn't it? Now I want to use a list comprehension. If you remember, our syntax is, so I provide my list name or the list I would like to get. So in the above for loop, you created an empty list. In here, you can see that you have combined the functionality. So in list comprehension, you're creating a new list, right? So what I'm doing, so list comp or list name, I can just specify list name. Okay, my list name and my syntax is use a square bracket, which will denote it's a list. As you can see, even in the above, you created an empty list with square brackets, right? So in here, I'm specifying it with my square bracket. I've got an expression part. So what expression would I want for my items within the, so this is my expression. Then I've got my for loop here. So for num in numbers, then I've got my if conditional statement, which is optional, so not necessarily I have to specify it. But in this below scenario, we are going to implement using the if condition, which is in the above, we are printing only the even numbers. Similarly, I'm using an if condition here to print only the even numbers. So even numbers is my list name. So my for loop goes like number for number in numbers. So num is my expression, and I'm using a for loop here for num in numbers. And here is my if condition. If number %2 is equal to 0, which again means that if the number is divisible by 2, it is an even number. So as long as the numbers are as an even number, you get to add it to your new list called even numbers list. Let's run this code. We have got the same answer. So 2, 4, 6, 8, 10 and 2, 4, 6, 8 and 10. Though both of my code examples have given me the same output, the list comprehension version is more concise. It is more efficient and it is more expressive as well. So your expression for now, it is just num, but there are other scenarios where you want to multiply your number, where you want to check the length of your number. So you have different kind of expressions that you can use within the for loop and your if conditional clause. So it doesn't matter. As you can see here, yes, it is printing the same result out. We have got the same result just by using a single line of code within our list comprehension. Hence, list comprehension is more efficient, it is more performant, it is very concise. It is more expressive line of code basically. So I hope this session was very useful to you. So make sure you check out on these video lessons again, just to be sure that you understand all the core concepts. Because while you listen, it would make sense to you that, oh, you know everything. But when you try to write this code, you are going to be worried about your how you are going to do it. So that's when your brain works on coding. And because this is all to do with logics, better keep it in practice. Okay, make sure whenever you're watching this video, you do hands-on, so that you get the better idea of how to do all these in your Python coding. So what have we covered today? We have covered about the indexing operation. So you get to access the element based on your index number you provide. You get to slice your elements or slice a subsection, a list from a list. Then you use a looping operation to iterate through each element within a list. Then you also saw about a list comprehension, where you write an efficient and a concise code. Simple. So I hope this lesson was very useful to you today. So make sure you subscribe to our channel. If you like this content, do give a like button. Do hit the like button and share the video with your fellow friends as well. so that they will be benefited as well. And if you haven't clicked the bell icon yet, feel free to click it so that you don't miss on the regular updates in our channel. And here is some happy news for you. If you're not aware, we also provide our training in different languages as well. So talking about the different languages, currently we provide for Tamil language, we provide for Telugu and English as well. So if you are comfortable with any other different regional languages, do check out Tamil and Telugu channel as well. And in the future, we are also planning to open up a Data Valley Kannada channel. So feel free to do that. And this is our website, Data Valley. So do check it out. We provide you with IT solutions, trainings, and placement assistance as well. Talking about trainings, we have multiple streams of subjects being taught, which are not the end of list, but few includes like data science, data engineering, data analytics, Python developer, Java developer, full stack developer, MERN stack developer, Snowflake developer. So we have multiple streams of subject being taught. So do check out our website. Feel free to get back to one of our colleague, and they'll make sure that you know everything about the Data Valley and how we could help you with your IT career. That is all for today. Hope this session was useful to you. So this is Franklin signing off. Do follow me in the LinkedIn so we can connect and build a community of professional technical people. So feel free to check out my profile. This is Franklin Florence. Thank you so much. Until then, I'll meet you in the next video. Bye bye. Take care.